Welcome back to the course Privacy and Security in Online Social Media on NPTEL. This is week number 10, and we're going to look at continuing the trend. We're going to look at another paper which is also looking at some of the security and privacy issues on online social media. This paper is $1 per RT, Boston Marathon, Pray for Boston, Analyzing Fake Content on Twitter. So I briefly mentioned this in the section Credibility and Trust. And if you remember, this was one of the tweets that I used in example also to say, please RT this tweet. We will pay $1 to Boston Marathon League. And all the otherwise the content in the title. Hashtag is Boston Marathon, Pray for Boston. I think in the later events also you would have seen such kind of hashtags. Pray for Paris was actually also trending when the Paris attack happened. Analyzing fake content on Twitter. So I'm going to go back to the content like the credibility that we saw, but then I just showed you some graphs and I moved on. Now we're going to actually see it in detail in terms of just paper writing. Paper is going to be our focus of this section. So if you look at the claims by this paper, we analyzed one such media, Twitter. Please remember this was actually published in 2013, 2012, during that period. So some of the mentions about the social media may be very, very basic. We analyzed one such media, Twitter, for content generated during the event of Boston Marathon blast that occurred on April 15th, 2030. So one of the results that the authors claimed is that 29% of the most viral content on Twitter during the Boston Marathon crisis were rumors and fake content. So this is how did they do it? They basically took the large set of rumors, large set of posts, asked users to annotate it, and they also got the true positive rumors from another source, looked at how much of the total content generated about the Boston Marathon had these posts, and therefore claimed that 29% of the most viral content were rumors, while 51% was generic opinion comments and the rest was true information. So this is the result of annotation that they did with the posts. Many malicious accounts were created. So there was a lot of malicious accounts that were created during the even just after the event, during the Boston event that were later suspended by Twitter. The authors identified over 6,000 such user profiles. We observed that the creation of such profiles surged considerably right after the blast occurred. So that's the, if you remember again, one of the themes that I've been mentioning across the course is actually finding out these profiles. How can you identify these profiles as fake profiles is one of the main goals of services like Twitter. And it is not that easy also, right? Given that this Boston Marathon blast has happened and the people are under panic, the criminals are actually making use of this situation in terms of creating the account and posting content which are rumors, and getting a lot of traction with it also. As we've discussed before, if somebody uses hashtag Boston Marathon, hashtag Pray for Boston, then it's going to be actually available to people who are interested in that hashtag, and therefore getting some rumors, getting some misinformation through this hashtag becomes much simpler. Right. That's the abstract of the paper. Now let's look at actually the introduction and methodology, data set, contributions, and the results that they have. So in the introduction, the authors actually mentioned generally about the Boston Marathon blast, what happened, and how the incidences panned out of the Boston Marathon. So the aim of this paper is to characterize and propose solutions to counter various forms of malicious activities on Twitter during events such as Boston Blast. Right. So the interest is to just characterize, create, see, and propose solutions to counter various. So one of the problems that they would take later is actually misinformation. Authors collected 7.8 million tweets, and later in methodology we'll see what kind of methodology, how did they actually collect the 7.8 million posts. So the data collection was limited from the fact that it was started 45 minutes after the blast. Interestingly, the way that these kind of data collections are done is that an event happens, and then we see that there is an event that has occurred, and there's some hashtag with the event that is trending. Take that hashtag, put it into the data collection, and collect the data. So this probably has some drawback. Also, in this case, it was 45 minutes. But the interesting thing is the 45 minutes thing. Again, the authors explain it later. But this 45 minutes also is interesting, is because authors actually looked at the posts that had come in this 45 minutes, and some of them are actually retweets. So essentially, the tweets that were tweeted even before 45 minutes is actually part of the data also here. And one of the other claims by the paper is the largest data set in terms of the rumors. So here are the tweets that I've shown you in a different context before, which is for every retweet we receive, we will donate $1 to Boston Marathon victims. Pray for Boston. So the handle is _Boston Marathon. That's not a real account. Hope for Boston. RIP to the 8-year-old boy who died in Boston's explosions while running for the Sandy Hook kids. Pray for Boston. Nothing. There was not a kid. The kid was not part of the Boston Marathon at all. There was no kid who took part in Boston Marathon and who actually was killed because of the blast. So this is just a background of the Boston Marathon itself. It's a twin blast occurred during Boston Marathon on April 15, 2013 at about 1850 GMT. 3 people were killed and 264 were injured in the incident. So now I'm looking at, so here is a picture that actually came out after the blast. And this was one of the first pictures, a picture clip during the Boston Marathon blast. So So the authors actually characterize the spread of fake content on Twitter using temporal, source, and user attributes. So you'll find some of the analysis in this paper are pretty simple, which is they would just the authors would just show you what kind of device that the users had when they posted the content. And because again, keep the year in mind. This is about 2013, so there is kind of the way that the authors look at it is slightly preliminary. Also, we found that approximately 75% of the fake tweets are propagated via mobile phones. They applied linear regression model to predict how viral fake content in future based on attributes and impact of users currently propagating the content. We analyzed the activity and interaction graphs for the suspended user profiles. One interesting thing that they did was the authors actually looked at the suspended user profiles and did analysis of what kind of users are these whose accounts were suspended. I think the last line here, I've said it multiple times in this course. Authors identified that malicious users exploit the event happening to indulge in e-crimes like impersonation and propaganda spreading. Others broke the related work into multiple categories. The first one is role of online social media during real world events. I think it's very clear that real world events, when it happens, it actually triggers the online social media content generation, which is when there is an earthquake, for example, there's Nepal earthquake, IPL cricket match, all of this is actually triggered a huge amount of content that is generated on online social media. So again, the authors go through in detail about the different types of events where social media has been involved. And then during the other category of events, the other category of literature that is available is actually assessing quality of information on online social media, which is to look at the misinformation, which is to look at what kind of content gets spread during this event, characterization of them, and how good or bad they are, and topics around it. There are even books now which actually look at this concept of misinformation on social media, big data. Right, so that gives you a sense of what the related literature is, related literature that you need to understand for this particular paper. Here is a very simple architecture that the authors had in terms of actually collecting and analyzing the data, which is keyword selection, manual keyword selection, that is the 45 minutes delay that I said, collect data from Twitter streaming API, which you all of you know, fake content tagging, select two most popular tweets, manually tag as fake, true, or neutral. So some kind of human annotation happens with the tweets that is from the event. Suspended profiles tagging, collect all user profiles suspended by Twitter who tweeted about Boston Marathon. So all the tweets that were, all the users that were suspended who had this Boston Marathon hashtag was looked at. Fake and temporal, spatial, source, impact, and suspended profile analysis, which is retweet reply network, user description, temporal analysis, tweet content. Essentially, the two parts of analysis done. One is the content from the event to understand the fake or misinformation. The other one is the suspended profile users. So if you look at the data collection, so this is what I said earlier. How did they collect this 7.9 million? They use the keywords called the person who was actually suspected, hashtag Watertown, hashtag Manhunt, Scene Collier, hashtag Boston Strong, hashtag Boston Bombing, hashtag One Boston, Boston hyphen Marathon, hashtag Pray for Boston, Boston Marathon with a space, hashtag Boston Blast, Boston Blast with a space, Boston Terrorist with a space, Boston Explosions with a space, Boston Health without a space, Boston Suspect. So using all this, so there is an interesting way of actually collecting all this. If you just know that hashtag Boston Marathon is what you're looking for, you take that hashtag, collect some 100 tweets, look at the frequency of the count of other words in it, take that, and then put them back into the search query and start collecting the data for that. Right. So that's the kind of, information retrieval kind of topic. This is referred as query expansion. You can take one query and then expand it as you would like. This data is about 7.9 million, and total tweets, total users, total URLs, tweets with geotag, retweets, replies, time of the blast, time of the first tweet, time of the first image of the blast, time of the last tweet. Basically to show you what distribution that the data has. The 45 minutes blast, so as I explained before, since in our dataset collection, this is the largest known data set, so they've explained it here. But since many tweets of the first 45 minutes got retweeted later, we were also able to capture those in our data collection mechanism. This is the largest known data set of Boston Marathon blast. Within 3 minutes of the blast happening, we got our first tweet. So, and there is also this interesting phenomena where you will actually see that the real world, that the content or the frequency of appearance of social media content is actually directly related to the events that are happening in real world, and the social media frequency are actually very much correlated. So here if you see, x-axis is the hours after the blast, y-axis is the number of tweets. Wherever the peak has happened, there is a direct correlation to the real world event. The first one being 1 hour after the blast, the second one being pictures of suspects released, and the third one being manhunters over. The Boston police used its official account to spread the photograph of the suspects and got aid in their manhunt. So one of the things that the authors actually analyzed during the event was that Boston Marathon, the legitimate account, started sharing pictures through the legitimate account to get inputs from the public itself, which was an interesting behavior by the police organization. So what the annotation that the authors did was they identified the top 20 most popular tweets during the Boston Marathon. In total, the 20 tweets constituted of 400,000 total tweets, which is 6%. Authors manually tagged these tweets in 3 categories: true, rumor, fake, and not available. NA stands for not applicable, and it represents tweets with neither give any true information or fake information about the event. They're mostly personal opinions and condolences. So if you remember in the abstract, we saw that about 50% of them are actually of this category. So 51 of this % of these are general comments and opinions. and the percentage of fake tweets was much more, 29%, than true information, about 20%. So that's the outcome of the annotation. So if you remember, many of the papers that we have seen, many of the research that we have seen, there is this human annotation done to learn the model, to understand how the real users react to these posts. There were about 3,249 overlap in the users who tweeted both true information and fake. 3% of 94,000 unique users who tweeted true information, and 2% of 147,000 unique users who tweeted fake information tweets. So essentially, this is saying that there are people who are posting both real and fake information. There are people who have 2% of the total number of unique users who posted fake information also. Temporal analysis. This is a graph that I've shown you in one of the very early lectures, I think about week 2 or something, where I kind of described what the spread of the rumor is. If you look at this graph, I'll make it short here. True information is actually starting much later than the rumor information, which is green color, and rumor is also spreading much faster than the real information. So there are ways to actually reduce it. One is to bring this real information earlier, it starts early, and the other solution is to get this rumor information fall flat very soon. These techniques can be achieved, then I think the spread of misinformation can be reduced a lot. Here is a table which actually gives you the full details about the events that the authors actually collected, posts that they had, which is tweet text, RTs, and categories. So this is the outcome of the manual annotation, and the authors are just giving you a sample of all the RTs that they had, which is in the decreasing order here, the category here. So the top RT was hashtag pray for Boston, which had about 87,000, and it's actually nothing is available, right? Pray for Boston. You can't really say whether it is actually malicious, legitimate, or it has no information. So now what authors did was they actually looked at, if you remember again, one of the contributions in the paper is to analyze the user accounts that were actually suspended. So what they do is they analyze the attributes and activities of the user accounts from where the fake tweets originated. Table 3 presents the various user profile attributes for the seed of the fake tweet user profiles. Of the 6 fake tweets identified, 2 users had started 2 rumors each. For most of the fake tweets, we observed that the seed users are people with few followers. Seed 4 is the only user profile with the high number of followers. The tweet posted by Seed 4 was reports of Boston marathon runners that crossed finish line and continued to run to Mass General Hospital to give blood to victims. So here are the 4 accounts that this paragraph was talking about. Number of followers. If you see the first 3 seeds, they're actually pretty small. So the point is that the rumors could be created by accounts who had followers are very small, but it gets spread fastly because somebody in the food chain of looking at these tweets who are more popular also looks at these tweets and posts it. So that's the one of the problem that you can actually look at also, how to actually reduce this particular post from this particular rumor from a user who does not have a large number of followers, going into the hands of people who are actually popular and actually retweeting them. Whereas Seed 4, if you see, it's actually 73,000 followers. That's the only account which is actually more popular, and it's also an active as per the data collection that was done. Here is the graph that I said before, which is the authors actually look at the true malicious and other information that is available through the device that which device was used. So A is all the fake information. In all the fake information, it looks like majority of them are actually using iPhone, and true information also, it seems to be the same, whereas the web is actually used more in terms of true information versus the fake information. And if you look at no information that is available, the web seems to be the highest. Right? This is generally only to get a sense of what kind of device are people using while posting. And the authors also do source analysis, which is what I said. Now let's look at the analysis of role of user attributes in fake content identification, which is what are the features of the users in terms of followers, in terms of whether the account is verified. How do they relate to the fake content that is getting propagated? The figure 8 actually shows you the content on the x-axis till 0 to 120 hours, y-axis to be the number of followers. It will clearly show that the first one is actually, the highest one is the not applicable tweets, then followed by the true content, and then followed by the fake content, which is the number of followers. The total number of followers, or the followers for the tweets that got propagated, which is fake, had the least number of followers. That's what you will see here. X-axis to be the hours, y-axis to be the number of followers, and the green triangle is actually at the lowest, showing that the followers for the fake content is the low. Then the red circles, which are the followers for the true content, and then the blue one, which is actually the followers for the not applicable content. If you look at the graph on the right, it actually shows you the verified account. Verified account also shows hours of the blast. There's a lot of content posted by a verified account which are not applicable and true later, whereas initially there is some content that are getting propagated by fake content is getting propagated by people who are actually our verified accounts. So this is the problem that I said, right? Initially people don't verify the content, people don't check what's going on. They have a verified account, they're just pushing this content, and therefore this content gets propagated much faster. So that's the role of user attributes in fake content identification. And there's this whole set of analysis that one can do in terms of actually propagating, analyzing the fake content. Right. So if you see here, there is concepts that are mentioned here. I'll briefly tell you what they are. Social reputation, which is like a cloud, global engagement, interactions with other users, topic engagement, linkability, credibility, all of this. So the authors basically what they did was they created, they had all these metrics, SR, G, T, L, and C, which is in the reverse order: credibility, linkability, topic engagement, global engagement, and social reputation. They used this and created a metric called impact. And what they were trying to figure out is that whether we can use these features, the 5 ones that I just now said, to predict what the impact of the post is going to be, or virality of the post is going to be, and things like that. The graph 9, the figure 9 on the right hand side here, actually shows you that it is possible to find out the propagation of the content using all these features. Right? So what does this show? Regression shows results of the overall impact of the users in previous time quantum. These results show us that it is possible to predict how viral the fake content would become in future based on the attributes of the users currently propagating the content. So they basically used followers, friends, favorited, status, verified, all of them to find out whether these information can be used to find the virality of the fake content that is posted on Twitter. So that's what they kind of show, that results of the model were compared with the individual features as well and represented in figure 9. On an average for the impact metric, we achieve approximately 0.7 value of R squared. These results show us that it is possible to predict how viral a fake information tweet would become in future based on the content attributes of the users currently propagating the fake content. Right? So that's about the analysis. So now let's look at the last analysis that the authors did was suspended profile analysis. They identified close to 32,000 Twitter accounts were created during the blast. And out of these, 19% were deleted or suspended by Twitter when we checked 2 months after the blast. So basically, since we had the post has a user has the ID, we went back and checked, authors went back and checked whether this particular user ID is there. If the user ID is not there, it was tagged that it was actually deleted. So figure 10 shows the number of suspended profiles created in hours after the blast. We observed that there are a lot of malicious profiles created just after they occur. So if you look at this figure 10, this graph shows the number of suspended profiles. So there were about 1,400 profiles that were suspended, which were just created few hours after the blast. Right? And similarly, you can also draw links between these handles. Figure 9 shows the networks obtained. Some of the users' names are anonymized. We have removed all the nodes with degree 0. We found that 69 nodes out of the 6,000 suspended profiles had an edge to another node in the graph. This basically shows that the handles which are propagating fake content are actually connected among themselves also. Single links. So we found 4 types of interactions among these accounts. Single links, they are not interacting with anybody. Closed community, there is a closed community. So here are the graphs. So these are all singletons. And then there is this closed network of people. Everybody is connected to everybody. And the other one is there is information spread only from one account to others. And there is also this self loops, which is each of them spreading. So I'm connected to you, you're connected to me, and I'm posting your content, you're posting my content. Right? So that's technically there are single links on the left one, closed community, star topology is the content, is the structure here, and self loops is the one here. Right, self loops. As some of the profiles mention themselves in that 2 is resulting in self loops in the graphs. So that's about the analysis that was done in this paper in terms of actually analyzing the fake content propagation in Twitter during the event Boston Marathon. And this is just not a comprehensive view of everything. It's just only one type of analysis. There have been many other papers which is looking at misinformation spread during a particular event. I'll leave you there, and then I'll see you soon.